Hello, student. In the next session of distributed systems, we are going to discuss about the communication. See, in the communication part, first thing is how many types of communications are possible in distributed systems are listed here. So the first type is a message oriented, second is stream, third is multicast, and last two are very important in terms of the implementation of the middleware and also the communication, how it will be possible in the procedure oriented and method invocation oriented. So in this session, we are going to discuss about the first three types of communication. And in next session, we are going to complete the next two communication parts. Okay. So what is communication first? So communication is nothing but exchanging of information between a number of devices. It includes 5 types of communications as we have just listed in the outline. So the first three types will be going to discuss in this session. Now, all the communications which we are discussing throughout the network level will be following OSI model. Okay. So for this, first of all, we'll be entering into the message-oriented communication. In the message-oriented communication, the sender and receiver will be in communication with each other. Thus, the procedure will be calling as a process every time, right? So the sending and receiving the messages explicitly between the sender and receiver is possible. So that kind of any kind of information starting from the processes or exchanging the resources or exchanging the information will be possible by this message-oriented communication. See, in this type, we will be again dividing the communication in the message-oriented with 3 types. So the first type is a synchronous, second is asynchronous, third is persistent. And along with this, we will be also knowing about the transient. So, and in the persistent and also in the transient, we will be also discussing the combination of synchronous and asynchronous. So first of all, let us know what is synchronous communication. So synchronous communication is nothing but once the sender send one message, immediately the other side, the receiver must take the message. So once the receiver takes the data, then only the sender will be sending the next message. Means once the sender send the data, unless and until the receiver receives it, the sender will be in the block mode, right? So the sender will be blocking the messages in the local buffer until the receiver receives the first message. So it will be in a sequential format. Next one is the asynchronous communication. In the asynchronous communication, the sender will be continuously sending the messages in the buffer slot. Whenever the receiver receives it, the receiver will be getting the data directly from the local buffer one after the other. So there is no guarantee that all the messages will receive the receiver. The sender will be continuously sending without having an acknowledgement that the receiver received or not. So one after the other, the messages will be continuously sent by the sender. So this is about the asynchronous communication. Now coming to the persistent communication. So this will be like a one-way communication type, but the receiver end will not be giving any acknowledgement, but the receiver will definitely receive the message. So in what way? So let us go with one example. So sender will be sending one data. At that time, receiver is not activated, not alert. So when the sender sent the data directly, it will be stored in the communication channel and it will be delivered to the receiver when the receiver will be in the active state. So let us take email system as one of the example. I want the data to be received to the receiver. But I don't know that either receiver is ready to receive now or not, but I'll be just sending it. Now, the receiver is not into the mail system at this moment. So after a few hours, the receiver opens the data, then the receiver will be getting the message from the inbox. So this is the type of the persistent communication. And this is very strong communication that it will be definitely delivered to the receiver. So these are the major three types of message-oriented communication. Along with this, we will be also discussing about the transit communication as we have committed for this. So in this communication also, the sender and the receiver will be sending sender will be sending the messages continuously throughout the receiver's application. See, receiver will be in a state of running state. So if the receiver is about to catch the data, they will be catching the data. Otherwise, the sender will be in the waiting mode unless and until the receiver is about to give the acknowledgement or is about to accept the data or is about to give one indication that I have received one, delivery message kind of thing. So here, the persistent synchronous can be discussed. See, in the first diagram here, A is about to send one message to channel B, right? So now A send the message continuously. See, this is asynchronous. So asynchronous is nothing but this is unaware that the receiver is ready to take the message or not. It will be just sending the messages. Now, persistent asynchronous means when the at that moment, B is not in running mode, so not in active state. When B starts, then immediately it will be receiving all the messages sent by A. So this is nothing but persistent asynchronous. Coming to the persistent synchronous, A will be sending the data until unless B accepts the data, A will not send a second message. Once it is sent by the sender and it is received or accepted by the receiver, then only A will be sending the next message. So like this, the message will be in a synchronized format in the persistent synchronous communication. Now we have transient asynchronous communication where the continuous flow of sending the messages from the sender side is happening and continuous the receiving of the messages at the receiver is taking place, right? So there is no indications given that I have received the message or else no acknowledgements, no delivery reports, right? And coming to the D, so in the D, this is a receipt based thing. So where A sends one data, immediately B will acknowledge that I have received so and so data. Then A will be sending the other data. So like this is acknowledge based. So thus it is called as receipt based transient synchronous. And coming to the E part here, this is delivery based. See, once we'll get WhatsApp is a double tick, so that indicates that the message has been delivered successfully. Similarly, here also, A will be sending the data and waiting for that deliver status of the message. Then immediately, B will be giving accepted message with that double tick message or whatever the symbol we are following in the network level. So immediately, we'll be getting the accepted status, that is nothing but delivery status successful. Then we'll be sending the another message. And last one is nothing but a response based. See, A has been sent one message. Immediately, B is taking the data, but something happened and it was about to send a request that I was accepted data and I want the data to be sent back, or else I have accepted the data, but I want your data process request to be accepted. So A will be sending and B will take some time and process the request and then it will give the accept. It will not give response immediately after receiving. After processing the request only, it will be giving the accept status. So these are many types of message-oriented communications. And then we'll be moving to the next type, that is stream-oriented communication. In the stream-oriented communication, as the name itself saying that continuous flow of data will be happening. So that may be bit by bit or byte by byte, whatever. But it may be again divided into two types, that is synchronous and asynchronous. When we are calling both together, we call it as asynchronous. So asynchronous can be defined as the status as both synchronous and asynchronous data transferring. Now, in this type of communication, the time plays an important role here because within this time, this stream of flow must be executed. Right. So let us go. I have created a video for 15 minutes. So within 15 minutes, our data will be streamed out and it will be stopped over there. Right. So there is no extra time given or it's less time given. So that is what the importance of stream orientation. It timing will be the important thing. And coming to the features, it is continuous data as we have known, and streams can be executed in the distributed formats also. And coming to the management of the stream, we have discussed two types. Those are asynchronous and synchronous. So asynchronous is nothing but there is no restriction to stop sending of the messages. We can send the continuous flow of the data. Synchronous is we can stop at one end, that is nothing but the time limit. Okay, we are going to have a timestamp or time limit. You have to stop your streaming over here, right? So coming to the characteristics of this, streams are always unidirectional flow. So as we are seeing TV every day, so that is only unidirectional. We can't give any input to the TV, but TV will be giving a lot of information to us, streaming continuously for us, right? So this is a basic important characteristics about that. And also it is a single source as we have seen every day. And nowadays all these can be in the hard drives also, I mean the hardware devices also, like a camera, CD drives and so on, right? Now last one is a multicast communication. See, multicast communication is nothing but there will be one sender and many receivers. Multiple receivers will be possible. So multicasting will be a combination of sending to many nodes at same time. So this will be organized by the overlay network. So overlay network will be a network which will be accepting an input from a sender and will be sent to n number of devices, n number of receivers in a tree structure format. So as we are seeing here, there is an overlay network which is having RA, RB, RC, and RT. So when A as an end host has been sent one data, so from B to C, B to D it is moving and D to C it is moving. So throughout the network to whatever the nodes which we are about to send the data in a tree structure, it will reach all the nodes in the network. So that is what the multicasting is, right? So till now we have completed the first three types of communication, and the next two types, that is RPC and RMA, will be seeing in the next session. Thank you.